Good evening and welcome to Cozy Sleep Time. Before we begin tonight's story, take a quiet moment to settle in and get comfortable. Find a position where your body can fully relax, whether you're lying in bed, resting on a couch, or simply unwinding after a long day. Allow your shoulders to soften. Let your breathing slow down, just a little. There is nowhere else you need to be, and nothing else you need to do. Here, on Cozy Sleep Time, we explore calm and gentle topics. Stories designed to help the mind slow down and drift peacefully toward rest. Each story moves slowly, gently, allowing your thoughts to wander and your body to relax more and more. Our story tonight is about the mountains, Earth's giants. As the story unfolds, you can simply listen, or you can allow your mind to drift. There is no need to stay focused. If your thoughts wander, that is perfectly natural. So take one more slow breath, get comfortable, and let the quiet story begin. Mountains are among the most dramatic and commanding features of our planet. Rising abruptly from the surrounding terrain, they dominate landscapes and shape the lives of everything that lives in their shadow. These massive formations have fascinated humans throughout history, appearing in the mythology and spirituality of virtually every culture that has encountered them. To understand mountains, we must first understand how they form. The Earth's outer shell, called the lithosphere, is broken into enormous slabs called tectonic plates. These plates float on a softer layer beneath them, moving slowly but constantly. When two plates collide, the massive force pushes rock upward, creating mountains. This process, called orogenesis, has built every major mountain range on Earth over millions of years. The Himalayas, home to Mount Everest, the world's highest peak, formed when the Indian plate collided with the Eurasian plate. This collision began about 50 million years ago and continues today, which is why the Himalayas are still growing. The force of these massive plates meeting has created mountain ranges that tower over 8 kilometers above sea level, an incredible height that represents the power of geological forces. Other mountains form in different ways. Volcanic mountains build up from eruptions, layer upon layer of lava and ash. Mauna Loa in Hawaii is the largest volcano on Earth, rising over 9 kilometers from the ocean floor to its summit. These mountains form when magma from deep within the Earth breaks through the surface, creating new land in the process. Block mountains form when large blocks of the Earth's crust are pushed up along faults. The Sierra Nevada range in California was created this way, a series of massive blocks tilted and pushed upward by tectonic forces. The distinctive shape of these mountains, with their steep eastern fronts and gentler western slopes, reflects the way the blocks were tilted during their formation. The height of a mountain is measured from sea level, but the base of most mountains lies well above sea level. The distance from the base to the summit is often far greater than the elevation above sea level suggests. Mauna Loa, for example, rises only about 4 kilometers above sea level, but measures over 9 kilometers from its base on the ocean floor. The tallest mountains on Earth are all in the Himalayas and surrounding ranges. The top 10 highest peaks are all over 8,000 meters, a height called the death zone because human survival without supplemental oxygen is impossible at those altitudes. These mountains represent the extreme end of what geological processes can create, conditions so harsh that only the most determined climbers can attempt to reach their summits. Mountains exist on every continent and beneath the oceans. The Mid-Atlantic Ridge, a chain of underwater mountains running through the Atlantic Ocean, is the longest mountain range on Earth. These underwater mountains form at the boundary where tectonic plates are spreading apart, with magma rising to fill the gap and create new ocean floor. The study of mountains, called erology, helps geologists understand the forces that shape our planet. By examining mountain ranges, scientists can reconstruct the history of tectonic plate movements and the geological processes that continue to reshape the Earth. Mountains are windows into the planet's deep history, revealing the forces that operate on timescales far beyond human experience. As we explore mountains further, we'll learn about the different types of mountains, the forces that shape them, and the unique ecosystems they support. These massive features are far more than just rock and snow. They are dynamic systems that affect climate, water, and life across the planet. Mountains may seem permanent and unchanging, but they are actually being constantly reshaped by powerful forces. Erosion and weathering work continuously to wear down even the highest peaks, carrying rock and soil away particle by particle. Understanding these processes reveals that mountains are not static monuments, but dynamic systems in constant change. Physical weathering breaks rocks apart without changing their chemical composition. In mountains, this often happens through frost wedging, a process where water seeps into cracks, freezes, and expands, forcing the rock apart. Each freeze-thaw cycle loosens another piece of rock, creating the debris that accumulates on mountain slopes. In very cold mountains, this process operates almost continuously during winter months. Chemical weathering changes the composition of rocks, dissolving some minerals and leaving others behind. Water, even pure water, can dissolve certain minerals, particularly in warm conditions. In mountains, this process creates the fine soil that eventually covers rocky slopes, transforming bare rock into surfaces where plants can eventually grow. The red colors seen in many mountain soils come from iron minerals that have been chemically altered. The most dramatic form of erosion in mountains comes from flowing water. Rain and meltwater carve streams into the landscape, cutting deeper valleys and carrying sediment downstream. Over millions of years, these streams can carve deep canyons and transform the landscape entirely. The Grand Canyon was carved by the Colorado River, a process that continues today as the river carries away rock and soil from the mountains where it begins. Glaciers are perhaps the most powerful erosive force in high mountains. These massive rivers of ice flow slowly down mountain valleys, sculpting the landscape as they go. Glaciers pluck rock from the valley walls, scrape the bedrock beneath them, and carry enormous amounts of material in their frozen masses. When glaciers retreat, they leave behind landscapes transformed, U-shaped valleys where rivers once carved V-shaped channels. The work of erosion creates distinctive mountain landforms. Horns form where 3 or more glaciers erode a mountain's slopes, creating sharp, angular peaks. Cirques are bowl-shaped depressions carved by glaciers at the head of valleys. Arêtes are knife-edge ridges left between 2 adjacent glaciers. These features, visible in any glaciated mountain range, record the history of ice on the landscape. The rate of erosion varies enormously between mountains. Some mountains are being uplifted faster than erosion can wear them down, like the Himalayas, which continue to rise. Others have reached a balance where uplift and erosion are roughly equal. In still other mountains, erosion has removed so much material that the range is now shrinking. The height of any mountain reflects the balance between these opposing forces. Erosion continues to shape mountains even as human activity affects the landscape. Deforestation in mountain watersheds accelerates erosion dramatically as roots that once held soil in place are removed. Development on slopes can destabilize soil, leading to landslides. Understanding the forces that shape mountains helps us make better decisions about how we use these environments. The ongoing erosion of mountains provides some of the most important resources we depend on. The sediment eroded from mountains fills river valleys with fertile soil, creating agricultural land downstream. The same processes create the gravel and sand used in construction. Even the water that flows from mountain snowpack and glaciers starts its journey as snow that fell on mountain slopes. These erosional processes remind us that mountains are not permanent. The mountains we see today will eventually be worn away, just as ancient mountains have been reduced to rolling hills. The energy that created them has not stopped. It has simply shifted to new forms of work, reshaping the landscape in an endless cycle of creation and destruction. Mountain ecosystems are among the most diverse on Earth, changing dramatically with elevation as temperature, oxygen, and weather conditions shift. From the lush forests at the base to the barren rock near the summit, each zone supports different communities of plants and animals specially adapted to its conditions. These vertical gradients of life are among the most striking features of mountain environments. The lowest elevation zone in a mountain supports forests that vary with climate. In temperate mountains, these forests are typically deciduous or mixed deciduous coniferous. In the tropics, they may be tropical rainforests. In dry climates, they might be shrublands. These forests are often the most diverse zones, with the greatest variety of plant and animal life. The trees provide habitat for countless species and regulate the flow of water through the watershed. Above the forest zone, where temperatures become too cold for trees, lies the subalpine zone. Here, trees become stunted, twisted by wind, and weighted by snow. These Krummholz forests, where the word Krummholz means bent wood in German, mark the transition to truly alpine conditions. The trees here are mostly conifers, their shape reflecting the harsh conditions they endure. This zone supports animals like mountain goats and pikas that are specifically adapted to life above the tree line. The alpine zone above the tree line is a world without trees. Here, low-growing plants dominate, including grasses, sedges, and dwarf shrubs. During the brief summer, alpine meadows burst into flower, providing a brief window of color before winter returns. Plants in this zone are adapted to extreme conditions, high winds, intense UV radiation, and temperatures that can drop below freezing in any month. The growing season may be only a few weeks long. The harshest conditions occur in the nival zone, above the snow line. Here, snow covers the ground for most of the year, and only the most specialized organisms can survive. Lichens and mosses grow on rock surfaces, slowly breaking them down and creating the thin soils on which other plants might eventually grow. Some areas may have no visible life at all, just bare rock and permanent snow. Yet even in this extreme environment, life persists in forms adapted to its challenges. The transition between zones is not abrupt but gradual, with each zone grading into the next. This creates a mosaic of habitats where species from different zones may overlap. The diversity of conditions across a mountain supports a corresponding diversity of species, making mountains some of the most biodiverse regions on Earth. This diversity also makes mountains vulnerable, as species have limited options for moving as climate changes. Animals have evolved numerous adaptations for mountain life. Mountain goats have specialized hooves that grip on steep surfaces and provide excellent traction on rock. Pika, small relatives of rabbits, have thick fur and can tolerate the cold temperatures of the high alpine. Birds like the wall creeper can walk up vertical cliff faces, hunting insects in habitats inaccessible to other predators. These adaptations reflect millions of years of evolution in mountain environments. Migration is one strategy animals use to cope with the harsh alpine winter. Many birds fly to lower elevations or migrate entirely out of the mountains. Some mammals, like mountain goats and bighorn sheep, move to lower slopes where snow is less deep and food is more accessible. Others, like pikas and ground squirrels, hibernate in burrows insulated from the cold. Each strategy represents a different solution to the challenge of surviving winter in the mountains. The vertical zonation of mountain ecosystems creates what scientists call an ecological staircase. As you climb a mountain, you travel through a series of environments similar to those you would encounter traveling north to the Arctic. A mountain in the tropics might have tropical forests at its base, temperate forests higher up, and Arctic conditions at the summit. This makes mountains valuable for studying how species respond to changing conditions. Water is the lifeblood of mountains, flowing from high peaks to fill rivers, fill aquifers, and sustain the populations that live below. The mountains act as water towers, capturing moisture from the air and releasing it slowly into the landscape below. This water supply supports agriculture, drinking water, and ecosystems across vast areas far from where the water originates. The water cycle in mountains begins when moisture-laden air is forced upward as wind encounters mountain slopes. As the air rises, it cools, and the moisture it carries condenses to form clouds and precipitation. This orographic effect means that the windward slopes of mountains receive much more precipitation than the leeward sides. This is why one side of a mountain range may be lush and green, while the other is a desert. Snow is the dominant form of precipitation in high mountains. The amount of snow that falls and how long it persists have enormous implications for water supply. In many mountainous regions, the spring melt of snowpack provides the majority of water for the growing season. This snowmelt flows into rivers, filling reservoirs and irrigating fields at exactly the time when crops need water most. Changes in snowpack therefore have major implications for water availability. The accumulation and melting of snowpack is a complex process. Snow depth and density determine how much water the snowpack contains, a measurement called snow water equivalent. As temperatures warm in spring, the snow begins to melt and water flows downslope. The timing of this melt depends on temperature, solar radiation, and the properties of the snow itself. A warm spell in late spring can cause rapid melting that overwhelms rivers. Glaciers are frozen reservoirs that store water in times of abundance and release it as they melt. For thousands of years, glaciers have provided a steady supply of water during dry periods, smoothing out variations in precipitation and ensuring that rivers continue to flow even when rain is scarce. Today, as global temperatures rise, glaciers are shrinking, raising concerns about future water supplies in regions that depend on glacier melt. When water reaches the base of a mountain, it flows into streams and rivers that carry it to lower elevations. These rivers carve canyons and valleys as they descend, creating the landscapes that characterize mountain foothills. The power of flowing water to carve rock means that even after the mountains themselves have stopped uplifting, rivers continue to deepen their channels, working slowly to reduce the mountains to gentler terrain. Groundwater is another important component of the mountain water system. Water that infiltrates the soil and fractured rock becomes groundwater, flowing slowly through the mountain's rock layers. This groundwater may emerge as springs lower on the mountain, or may flow to the surface in valleys at the mountain's base. In many mountainous regions, groundwater provides the majority of drinking water, a resource that can persist through dry periods when surface water is scarce. Changes in mountain water systems are among the most significant consequences of climate change. Higher temperatures mean that more precipitation falls as rain instead of snow, reducing the storage capacity of the snowpack. Warmer springs cause earlier melting, changing the timing of water availability. Glaciers are shrinking, threatening the long-term water supply they have historically provided. These changes have implications that extend far beyond the mountains themselves. The management of mountain water resources is a complex challenge. Dams capture water for storage and power generation, but also alter the natural flow of rivers. Diversions transport water to distant cities and agricultural areas. Watershed management aims to protect water quality while allowing sustainable use. Each decision about how to use mountain water has consequences for ecosystems and for the people who depend on that water downstream. Climate changes dramatically with elevation in mountains, a relationship that has profound implications for both ecosystems and human activity. As you climb higher, temperatures drop, oxygen becomes scarcer, and weather becomes more extreme. Understanding these gradients helps explain why mountain environments are so varied and why they are so sensitive to change. Temperature decreases with elevation at a rate called the lapse rate, typically about 6 to 10 degrees Celsius per 1,000 meters of elevation gain. This means that if the temperature at the base of a mountain is 25 degrees Celsius, the temperature at a 4,000 meter summit might be only 5 degrees. This temperature drop is one of the primary reasons for the different ecosystems found at different elevations, creating the vertical zonation that characterizes mountains worldwide. Oxygen availability also decreases with elevation, a factor that affects both human physiology and the distribution of life. At very high elevations, the partial pressure of oxygen is so low that human bodies cannot get enough to function normally. This affects everything from exercise capacity to cognitive function. Animals that live at high elevations have evolved special adaptations, including more efficient oxygen use and greater lung capacity to cope with these conditions. Air pressure decreases with elevation, affecting weather patterns and the boiling point of water. At high elevations, water boils at temperatures well below 100 degrees Celsius, meaning that cooking times must be adjusted and certain foods cannot be prepared normally. The lower air pressure also means that the atmosphere provides less protection from harmful solar radiation, explaining why sun exposure is a greater problem at high elevations. Weather in mountains is far more variable and extreme than in surrounding lowlands. Mountains act as barriers to airflow, forcing air to rise and often creating their own weather systems. Wind speeds are typically higher on exposed peaks and ridges. Storms develop quickly in mountain areas, and weather can change within minutes from clear to dangerously stormy. This unpredictability makes mountains hazardous places, even for experienced climbers. The effect of mountains on climate extends far beyond their immediate slopes. Mountains influence regional weather patterns, creating wet windward slopes and dry leeward areas. This rain shadow effect can create deserts in the lee of major mountain ranges. The Tibetan Plateau, often called the roof of the world, influences the Asian monsoon system that affects billions of people. Mountains shape climate at scales ranging from local to continental. Mountain climates are changing faster than those at lower elevations. This accelerated warming, which scientists call elevation-dependent warming, means that high-altitude ecosystems are among the most vulnerable to climate change. Species that live in these environments have limited options for moving to cooler locations as temperatures rise. The mountaintops they inhabit may become too warm for them to survive. The changing climate is already affecting mountain environments in visible ways. Glaciers are retreating worldwide, leaving behind newly exposed rock. The timing of snowmelt is shifting, changing when water becomes available. Species are moving upslope, eventually running out of mountain to climb. These changes are visible evidence of the larger changes happening across the planet. Understanding mountain climate helps us prepare for the changes yet to come. The unique sensitivity of mountain environments makes them valuable indicators of broader climate change. The changes we observe in mountains today preview what will eventually happen at lower elevations. By studying mountain climate, we can learn what to expect and how to respond. People have lived in mountains for thousands of years, developing cultures and ways of life shaped by the challenging environment. High mountain communities exist on every continent, their traditions and identities deeply connected to the peaks and valleys they inhabit. These mountain peoples have much to teach us about living sustainably in challenging environments. Agriculture in mountains requires specialized techniques adapted to steep slopes and short growing seasons. Terracing, the practice of creating level platforms on hillsides, allows farmers to grow crops on slopes that would otherwise be too steep. These terraces, found in mountains worldwide from the Andes to the Himalayas, represent generations of work to make these suitable for farming. The technique prevents erosion while capturing water and creating fertile soil. The crops suited to mountains differ from those in lowlands. Potatoes, which originated in the Andes, thrive in cool mountain conditions and provide reliable nutrition at high elevations. Barley and other grains can grow at elevations where other crops fail. Specialty crops like tea and coffee grow well on mountain slopes, where drainage is good and temperatures are moderate. Mountain agriculture produces some of the world's most distinctive and valued products. Pastoralism, the raising of livestock on natural grasslands, is the primary livelihood in many mountain regions. Sheep, goats, cattle, and yaks graze on mountain meadows, converting vegetation that humans cannot eat into meat, milk, and other products. Moving the herd to different pastures with the seasons, herders make use of the varied conditions across the mountain. This mobility is essential for maintaining the health of both the animals and the grasslands. Mountain communities have developed distinctive architectural styles suited to their environment. In the Himalayas, stone houses with flat roofs provide protection against heavy winter snowfalls. In the Alps, chalets with steep pitched roofs shed snow efficiently and provide space for storing hay. In the Andes, buildings with thick walls moderate temperature extremes. Each style reflects the specific challenges of its mountain environment. Traditional mountain festivals and ceremonies often celebrate the relationship between communities and their environment. In the Himalayas, the harvest festival of Dasein honors the gods who protect the crops and livestock. In the Alps, the Alpine Festival marks the end of summer and the beginning of the autumn migration to lower pastures. These celebrations connect mountain peoples to their landscape and to each other. Mountain communities face unique challenges in the modern world. Isolation makes access to education, healthcare, and markets difficult. Depopulation, as young people leave for cities, threatens traditional ways of life. Climate change affects the patterns of agriculture and pastoralism that have sustained mountain peoples for generations. Yet mountain communities also offer lessons in resilience and adaptation that are increasingly relevant in a changing world. Tourism has become a major force in many mountain economies, bringing both opportunities and challenges. Ski resorts and hiking destinations provide employment and income, but can also damage environments and displace traditional land uses. The challenge is to develop tourism in ways that benefit local communities while protecting the mountain environments that attract visitors in the first place. The connection between mountain communities and their environment offers lessons for us all. These communities have learned to live within the limits of their environment, using resources sustainably over generations. Their traditional knowledge about crops, herding, and forest management offers insights that may be valuable as we face the challenges of climate change and environmental degradation. Mountains have always held a special place in human imagination, appearing in the myths, religions, and art of virtually every culture. The sheer mass and commanding presence of mountains evoke feelings of awe, fear, and reverence. This significance goes beyond practical considerations of resources and environment, touching something deeper in the human psyche. In many cultures, mountains are sacred, the homes of gods or the abodes of spirits. Mount Olympus in Greece was home to the Greek gods. Mount Kailash in Tibet is sacred to multiple religions, including Buddhism, Hinduism, and Jainism. In Japan, mountains are inhabited by kami, spirits that must be respected. The tops of mountains, closest to the sky, are places where the boundary between the human and divine seems thin. The word sublime, used to describe mountains, captures the particular quality of response they evoke. When we stand at the base of a massive peak or gaze across a sea of mountain ranges, we feel something beyond ordinary experience. This feeling has inspired poets and painters for centuries, from the romantic painters of the 18th century to the photographers of today. The mountains offer an encounter with something greater than ourselves. Mountains appear in creation stories from cultures around the world. In many myths, the world began on a mountain, or mountains were the first land to emerge from the waters. The sacred mountain is a universal symbol, representing the connection between earth and sky, between the human and the divine. This symbolism reflects the actual physical properties of mountains, which are the closest land to the heavens. Climbing mountains has been both a practical necessity and a spiritual practice for mountain peoples. The act of climbing, of reaching a summit, has taken on meaning beyond the physical achievement. The view from the top, the sense of having arrived somewhere significant, connects climbers to something larger than themselves. This experience is not unique to any culture, but appears wherever there are mountains to climb. The spiritual significance of mountains continues today, though often in secular forms. People climb mountains to challenge themselves, to prove something, to see the world from a new perspective. The climb is a metaphor for life's challenges, the summit a symbol of achievement. Even those who never climb may feel drawn to mountains, understanding on some level that they represent something important. Mountains inspire scientific curiosity as well as spiritual feeling. Geologists study mountains to understand the forces that shape our planet. Ecologists study mountain ecosystems to learn how life adapts to extreme conditions. Climbers document how their bodies respond to altitude, contributing to medical knowledge. The mountains offer opportunities for learning that are as valuable as their spiritual significance. The meaning we find in mountains is shaped by our cultural background and personal experience. Some see mountains primarily as resources to be used. Others see them as wilderness to be preserved. Still others see them as sacred spaces to be protected from development of any kind. These different perspectives on mountains reflect different values and different relationships with the natural world. As we consider what mountains mean to us, we might reflect on our own relationship with these massive forms. Do we see them as opportunities for recreation? As symbols of something larger? as places to be protected? The answers we give reveal something about our values and our understanding of our place in the natural world. Mountains, in their permanence and power, offer a mirror for thinking about our own lives and purposes. The economic value of mountains extends far beyond the immediate resources they provide. Mountains influence economies at scales ranging from local to global, affecting everything from tourism to water supply to climate. Understanding this economic importance helps explain why mountain environments are worth protecting and managing sustainably. Mining has been important to mountain economies for centuries. The ores found in mountains, from copper and gold to silver and lead, have built fortunes and fueled industrial development. Even today, many of the world's most productive mines are in mountains, where geological processes have concentrated valuable minerals. The environmental impacts of mining, however, have raised questions about whether the benefits justify the costs. Hydroelectric power generation is one of the most valuable uses of mountain water. The steep slopes and abundant water supply in mountains create ideal conditions for generating electricity from flowing water. Dams in mountain valleys capture water that can be released through turbines to produce clean, renewable power. Many countries get a significant portion of their electricity from mountain hydroelectric projects. Tourism is perhaps the most visible mountain-based industry. Ski resorts, hiking destinations, and mountaineering attractions bring millions of visitors to mountain regions each year. The economic impact of this tourism can be enormous, supporting hotels, restaurants, guide services, and equipment suppliers. Yet tourism can also cause environmental damage and cultural disruption if not managed carefully. Agriculture in mountains produces some of the world's most distinctive foods. The unique conditions of mountain environments, including the short growing season and the intense sunlight, create flavors found nowhere else. High-quality teas, coffees, and fruits grow on mountain slopes in various parts of the world. The specialty products command premium prices that support mountain communities. Forests covering mountain slopes provide valuable timber, as well as ecosystem services like water regulation and erosion control. The trees that grow in mountains may grow more slowly than those in lowlands, but the wood is often denser and more durable. Managing mountain forests sustainably is challenging, as the steep slopes make logging difficult and potentially damaging. The services that mountain ecosystems provide are often more valuable than the products extracted from them. The water that flows from mountains supports agriculture, drinking water, and industry far from the mountains themselves. The carbon stored in mountain forests and soils helps regulate the global climate. The beauty of mountain landscapes attracts tourists whose spending supports economies throughout the region. Balancing economic development with environmental protection is a challenge in mountain regions. The steep slopes and fragile ecosystems of mountains are easily damaged by development. Roads, dams, and buildings can cause erosion, alter water flow, and destroy habitat. Yet economic development can improve the lives of mountain communities, who often have few other options for improving their standard of living. The challenge is to develop mountain resources in ways that are sustainable over the long term. This means considering not just the immediate benefits of any development, but also the long-term costs to the environment and to future generations. It also means involving mountain communities in decisions about how their resources are used, ensuring that they benefit from development rather than bearing the costs while others reap the profits. Mountains are among the most vulnerable environments on Earth, facing threats from climate change, development, and resource extraction. These threats interact in complex ways, making mountain ecosystems particularly difficult to protect. Understanding the challenges facing mountains is the first step toward finding solutions that can preserve these irreplaceable environments. Climate change affects mountains more severely than most other environments. Temperatures are rising faster at high elevations, a phenomenon called elevation-dependent warming. This means that the ecosystems adapted to cold mountain conditions are experiencing the greatest changes. Species that have nowhere to go as conditions warm are being pushed toward extinction. Glaciers are shrinking, threatening the water supplies on which millions depend. Deforestation in mountain watersheds has multiple negative effects. Removing trees eliminates habitat for wildlife, releases stored carbon into the atmosphere, and removes the root systems that hold soil in place. The resulting erosion fills reservoirs, clogs rivers, and increases flooding risk. In the long term, deforestation can transform mountain slopes from productive forest to barren rock. Mining and drilling operations in mountains cause environmental damage that can last long after operations end. The cleared land, tailings ponds, and roads create scars on the landscape. Pollution from these operations can enter waterways and contaminate water supplies. The social impacts, including the influx of workers and the disruption of traditional communities, can be as significant as the environmental impacts. Overgrazing by livestock degrades mountain grasslands, particularly where herds are larger than the land can support. The compacted soil from animal hooves prevents water infiltration, increasing runoff and erosion. The preferred plants are eaten while less palatable species spread, changing the composition of the vegetation. The loss of cover leaves slopes vulnerable to erosion and landslide. Tourism, while economically valuable, can also damage mountain environments. The infrastructure needed to support visitors, from ski lifts to hotels to restaurants, requires clearing land and altering natural landscapes. The crowds of visitors can damage sensitive vegetation and disturb wildlife. The huge water demands of ski resorts can strain local water supplies, particularly in areas where water is already scarce. The solutions to these problems are not simple, but they exist. Protecting watersheds requires controlling development and preventing deforestation in critical areas. Sustainable forestry and agriculture practices can provide economic benefits while maintaining environmental function. Managing tourism carefully can minimize impacts while preserving the economic benefits. The key is recognizing the value of mountain environments and making protecting them a priority. International cooperation is often necessary to protect mountains, as many mountain ranges span multiple countries. The waters that originate in mountains flow across borders to benefit populations far from the peaks. Protecting these shared resources requires agreements between nations and coordination of management practices. Organizations like the Mountain Partnership work to bring countries together to protect mountain environments. Individual actions also matter. Supporting organizations that work to protect mountains, making sustainable choices in what we consume, and reducing our carbon footprint all help. When we visit mountains, being careful to minimize our impact and respecting the communities and ecosystems we encounter makes a difference. Every action that reduces pressure on mountain environments contributes to their protection. The geological history of mountains is written in the rocks that form them. By studying these rocks, scientists can reconstruct the processes that created the mountains and the history of the Earth itself. The story of mountains is ultimately the story of our planet, told in stone. The rocks in many mountains began as sediments deposited in ancient seas. Over millions of years, these sediments were buried, compressed, and transformed into sedimentary rock. The horizontal layers in some mountain rocks record the conditions in these ancient seas, with different layers representing different times and environments. Fossils in these rocks reveal the life forms that existed when the sediments were deposited. Many mountain rocks have been deeply buried and transformed by heat and pressure. This transformation, called metamorphism, produces new minerals and new textures that record the conditions deep within the earth. Schist, gneiss, and marble are all metamorphic rocks that can be found in mountain ranges, each telling a story of burial and transformation. The processes that create these rocks operate far below the surface, but mountain building brings them to light. Igneous rocks, formed from molten magma, also figure prominently in many mountains. Granite, the most common igneous rock in continental mountains, forms from magma that slowly cools deep underground. When the mountains above are eroded away, the granite is exposed at the surface, forming the distinctive domes and peaks seen in places like Yosemite. Volcanic mountains are built from lava that erupted onto the surface, cooling to form rocks like basalt. The structure of mountains, the way rocks are folded and faulted, records the forces that created them. When tectonic plates collide, rocks are compressed and folded, the layers buckling like a rug pushed from both ends. The tilted rock layers seen in many mountains are evidence of this compression. Faults, where rocks have broken and slid past each other, record the sudden release of stress that sometimes accompanies mountain building. The age of mountain rocks can be determined using radiometric dating techniques. These methods measure the breakdown of radioactive elements in the rocks, calculating how long it has been since the rocks formed. Some mountain rocks are over 3 billion years old, dating from the earliest period of Earth's history. Other mountains are very young, still forming today. The age of the rocks tells us how long the mountains have been rising. The erosion of mountains reveals their geological history in dramatic ways. When glaciers carve their way down mountain valleys, they expose the rocks beneath, making the internal structure of the mountain visible. The cliffs and ridges of high mountains show the patterns of rock layers, the intrusions of magma, and the effects of metamorphism. Erosion has removed the cover that once buried these rocks, revealing the history they contain. The study of mountain geology has revealed patterns in how Earth works. The recognition that mountain ranges form where tectonic plates collide was one of the key discoveries in understanding plate tectonics. The pattern of ancient mountain ranges, now worn down, shows where plates have collided in the past. These patterns help geologists understand both past and future mountain building. The geological story of mountains continues today. The forces that built mountains have not stopped, merely slowed. In some mountains, like the Himalayas, uplift continues as plates collide. In others, like the Appalachians, the forces have long since ceased, and erosion is slowly wearing the mountains down. Each mountain range tells a story that began millions of years ago and continues today. Mountains have inspired exploration and adventure throughout human history. The desire to reach the summit, to see the view from the top, to challenge oneself against the mountain has motivated climbers for centuries. This spirit of adventure continues today, drawing millions to mountains around the world each year. The history of mountain climbing is long and storied. People have climbed mountains for practical reasons for thousands of years, searching for resources, crossing passes, or traveling between communities. The recreational climbing of mountains as a sport began in the 18th century in the European Alps, when guides began taking tourists up peaks for a fee. Since then, climbing has evolved into a global pursuit with many styles and traditions. High-altitude climbing presents challenges unlike any other. The thin air at extreme elevations makes physical exertion difficult and can cause serious illness. Climbers must acclimatize gradually, spending time at intermediate elevations to allow their bodies to adjust. The weather on high mountains is unpredictable and dangerous, with storms that can appear without warning and temperatures cold enough to cause frostbite in minutes. The techniques of climbing have evolved over time. Early climbers used simple equipment, relying on skill and experience rather than gear. Modern climbers have an array of equipment designed to make climbing safer and more accessible. Ropes, harnesses, and protective gear allow climbers to attempt routes that would have been impossible in earlier eras. Yet the fundamental challenge remains the same: moving safely over difficult terrain. Mountaineering ethics have developed over time to guide how climbers should interact with the mountain and with each other. These ethics cover everything from how to treat the natural environment to how to treat other climbers. Many of these ethics emphasize safety, sustainability, and mutual assistance. The mountaineering community takes these ethics seriously, and violations can lead to criticism and exclusion. Famous mountains have become icons in the climbing world. Everest, the highest mountain, has drawn climbers since the first attempts in the 1920s. The faces of Yosemite have been the proving ground for generations of rock climbers. The Alps, where modern climbing began, remain a training ground for climbers learning their craft. These famous mountains represent both the challenge and the tradition of the sport. The risks of climbing are significant. Even experienced climbers die each year in accidents on mountains around the world. Falls, avalanches, altitude sickness, and equipment failures all claim lives. The commitment required to climb at the highest levels means that climbers must accept these risks as part of the pursuit. This acceptance, combined with careful preparation, is what makes high-altitude climbing possible. For most people, mountaineering is not about reaching extreme altitudes or climbing the most difficult routes. It is about the experience of being in mountains, of climbing within one's abilities, of enjoying the challenge and the beauty. The millions who hike on mountains each year share in this experience, even if they never climb a technical route. The mountains welcome all who come to experience them. As you explore mountains in your own way, whether through climbing, hiking, or simply visiting, remember that you are joining a long tradition of people who have found meaning and inspiration in these massive forms. The mountains are unchanged from what previous generations encountered, though the ways we experience them may differ. The call of the mountains continues to draw us upward. The future of mountains is uncertain as climate change transforms these environments at unprecedented rates. The changes happening in mountains are among the most visible signs of the larger changes occurring across the planet. Understanding what is happening helps us prepare for the consequences and work to slow the changes that are causing it. Glaciers worldwide are retreating as temperatures rise. These frozen reservoirs, built up over thousands of years, are shrinking rapidly. In some places, glaciers that have existed for millennia may disappear within decades. The loss of glaciers affects water supply for millions of people, changes the appearance of iconic mountain landscapes, and releases stored water that temporarily increases river flow before eventually decreasing. Snowpack is decreasing even where temperatures remain cold enough for snow. Earlier spring melt means less water is stored for the summer months. Warmer winters may bring rain instead of snow in some areas. changing when and how water is available. The ski industry, which depends on reliable snow, is already being affected in many regions. These changes have implications far beyond the mountains themselves. Species that live in mountains are being squeezed between warming lowlands and the top of the mountains where there is nowhere higher to go. As temperatures rise, species shift upslope, eventually reaching the summit where there is no more mountain. At that point, they must either adapt to new conditions or face extinction. Many species cannot adapt quickly enough and are declining. Vegetation is changing as conditions shift. Tree lines are moving upslope, pushing into areas that were previously too cold for trees. Species from lower elevations are spreading into areas once dominated by alpine vegetation. These changes affect the appearance of mountains and the ecosystems they support. Some changes are subtle and only become apparent over time. The rate of change in mountains is accelerating. What once took centuries now happens in decades. The systems that have shaped mountains for millennia are being disrupted. The consequences are visible in shrinking glaciers, shifting vegetation, and changing water availability. These changes are not just interesting to observe. They have serious implications for the billions of people who depend on mountains for water, food, and other resources. Responding to these changes requires action at multiple scales. Reducing greenhouse gas emissions is essential to slow the pace of change. Adapting to changes that are already inevitable requires different strategies, from building new water infrastructure to adjusting agricultural practices. Protecting mountain ecosystems can help them resist some impacts and recover more quickly from others. Mountains have always been places of change. Erosion slowly wears them down. Tectonic forces slowly push them up. The climate has changed before, and mountains have changed with it. What is different now is the speed of change and the human role in causing it. We have created this situation, and we have the ability to do something about it. The mountains will continue to exist long after the current crisis passes, though they will look different than they do today. The question is whether we will act to preserve the values we find in them, or simply allow them to be transformed by change. Our choices will determine the mountains our grandchildren inherit. As we conclude our exploration of mountains, we can reflect on what these massive forms mean to us. Mountains have shaped human culture, economy, and spirituality throughout history. They provide water, resources, beauty, and inspiration. They challenge us physically and mentally. They remind us of the power and beauty of the natural world. The experience of being in mountains, whether climbing, hiking, or simply visiting, connects us to something larger than ourselves. The scale of mountains puts our daily concerns in perspective. The beauty of mountain landscapes moves us in ways that are hard to articulate. The challenge of climbing tests our limits and rewards us with a sense of achievement. Mountains teach us important lessons about time and change. The rocks that form mountains took millions of years to accumulate, and the mountains themselves took millions of years to rise. They will eventually wear down again, their rocks becoming the sediments of future landscapes. The timescale of mountains far exceeds human experience, reminding us that we are part of a much larger story. The protection of mountains matters for many reasons. They provide essential services from water supply to climate regulation. They harbor irreplaceable biodiversity, species found nowhere else. They hold spiritual significance for cultures around the world. They simply make the world a more beautiful place. Each of these values is worth protecting. Our relationship with mountains continues to evolve. The days of treating mountains as inexhaustible sources of resources are ending. The recognition that mountains need protection is growing. The challenge is to find ways to enjoy mountains while protecting them, to use their resources sustainably, and to preserve their wild character for future generations. As you drift off to sleep, imagine the mountains you know or have visited. Recall their shape, their scale, the way they changed with the light. Think of the water that began its journey on their slopes, the creatures that make their home in their varied elevations, the people whose lives are shaped by their presence. The mountains are always there, steady and patient, as they have been for millions of years. Sleep now, knowing that somewhere in the world, the sun is hitting a mountain peak, casting long shadows across a glacier, warming the rocks where a mountain goat stands watch. The mountains continue their ancient work, unchanged by our brief passage. Tomorrow, they will still be there, waiting for us to return and explore their wonders again. Sweet dreams. As our story slowly comes to an end, allow the final thoughts to fade. Gently into the quiet of the night, the rain and the calm ideas and the peaceful moments we've explored can settle softly in the background like distant echoes of a quiet evening. There is no need to think about anything now. Your body can continue to relax, breathing slow and steady. If you are still awake, simply remain here a little longer and enjoy the calm atmosphere. And if sleep has already started to find you, let it arrive naturally and without effort. Thank you for spending this quiet moment here on Cozy Sleep Time. If you enjoy these calm stories and gentle explorations, you can return anytime for another peaceful journey into rest. For now, let the night grow quieter and quieter and quieter and allow yourself to drift deeper into sleep. Good night.